Hi guys. My name is Jonathan Lee, and today I'm going to be explaining the Rust ownership and references. So Rust is different. Rust language is different from the other programming languages because it is a linear type system. Linear type system. What does that mean? This means that there can only be one owner of a variable at a given time. At any given time. Okay, so I'm going to show you what I mean. So over here I have the main Rust function, and here I've defined a structure called a person. Age is going to be just an I32, and so here in this line I create a person of age 5, and I print out the person's age. Then over here I say let q equals to p, and that effectively transfer the ownership of a person to q. And so I print out q's age, which is 5, and then after that, when I try to access p's age, it'll throw an error because p no longer owns the person, q does. So I'm going to run it and see, just like I said, there's an error. So what is this saying? Okay, there's one owner in Rust. Okay, so think of something like books. Okay, so this is P for Patty, for example. Patty owns a person. Okay, let's say the person is like a book. Okay, treat it like a book. Okay, so Patty owns like a physical like book, and then she can access the age of the book. But over here, Patty is giving the book to Quentin, for example, and then Quentin has the book, so Quentin can access the age. But when you're trying to ask Patty for the age now, Patty says, "Look! I don't own the book anymore. I gave the book to Quentin, so I can't give you the age. I don't have access to it anymore. I'm no longer the owner." So that's how it works. So that is ownership, one owner at a time. So it's either I own it, a variable. Either I own it, you own it, like he owns it. Like one person can own it. You can't. It's not like, oh, all 5 of us we own this thing collectively. No, there can only be one owner. So in that way, Rust is very strict with ownership. So now we have ownership down, like covered. We can talk about references, which is a little bit more complicated. So let's get into that. So right now, you're saying Q is going to take the ownership from P. But what if you want Q to just borrow? You just want Q to just borrow from P, right? So P owns the person, but you want Q to borrow. If you want to borrow, you just put an ampersand in front. This says P owns person, and then Q borrows from person. And when you print, it's going to print 5, 5, and 5. Okay, so you can actually do this type of borrowing is called a read-only borrowing, or read-only reference, right? Q is a reference to P. You can do multiple of these. So QR equals, so R equals reference to P. You can do let S is equal to reference to P. You can do all sorts of stuff. And then you can say print. You can do R dot age, right? You can do print S dot age, right? And if you do these, they'll all work. So you can do, if you want to, you can just do a bunch of borrows if you want. You can do let T, let U, let V, and you can just make a bunch of variables, and they all equal to ampersand P. So they all borrow from P. That's fine for read-only borrow. Here's the thing though, while P is being borrowed, it cannot be read, which is kind of strange. Actually, it should be. It's read. It's readable. See, while P is being borrowed, read only. You can access P age. You can access Q age. R, S. All of these, like these 3, they refer to P, and you can access the age. And then P, you can access the age, because right now, when you set a let P, you're saying that create a P, but this P never changes. Either it exists or it dies. Like, you can't change. If you want to change this age to 6 or something, you couldn't, because it's just let P. So I'll show you what I mean. So right now you have P.age, right? You're saying, okay, I want to change P.age equal to 6. And then I want to print and then I want to print p.h. If you do that, it'll fail. It won't work because p is not mutable. If you want p to be mutable, then you put a mut. You put mut or mute, whatever you want to call it. I like to call it mut, but it's mute, whatever you want to call it. Okay, when you put this keyword mut in front of p, what this does is saying, hey, p is now mutable. So this line of code now works. And when you run it, you'll see that, okay, it's printing 5, and then you can change p to 6, and then p is now 6. Okay, that's good. So let's review the code back, this code over here. So if Q is borrowing from P, R is borrowing from P, and S is borrowing from P, right? So when you do a print, there are some warnings. This warning's telling you, oh, you don't need that mutable because like you really don't need the mutable, but whatever. I'm just gonna ignore this warning, okay? But you can see that all these prints are working. Here, I'll show you something kind of profound though. While P is being borrowed by anything, while P is being borrowed, you cannot change P. Okay, so if over here, right? If over here I decided like to say, okay, so Q, R, and S are all borrowing from P, right? And I want to say P dot H is equal to 6. I want to do this. This code will fail. It fails. And the reason why it fails is because when P is being borrowed by Q, R, and S, if you were to change P.H to 6, then, like, if you think about it, that would mean that Q would also have to change its age, and R would have to change its age, and S would have to change its age, and that's just a lot of work to go through. So for Rust, they just created a rule that says, while P is being borrowed mutably, like with it, even though P is supposed to be mutable, like P can be changed, it has a capacity of being changed. You can't change it when it's something's borrowing it. If you were to take these 3 away and P were not being borrowed, then sure you could change it. So that is read-only, just like regular references. There are actually 2 different types of references in Rust. So I'll get to the second type. The first type of borrowing was just let t equals and p, right? And with this one, t is read only p, right? So with this t, you can read the value of p. So if you were to access t.h, it would work. But if you were to say t.h is equal to 6, then it would fail. Because t is read-only p. Like, t can only read p, right? T is, like, pointing to p. So it's pointing at p, but it's not capable of changing p. If you want t to be able to change p, you would do a mutable reference, which is ampersand mut. And when you do this, then t is capable of changing p. So here, I'll just try this again, and it'll work, okay? So over here, of course, you're printing out p, and here you're printing out t, which is t is borrowing p mutably, and then after you change t's age to 6, then you print out t.h, it'll be 6. Okay, this is mutable borrowing. This is read and write borrowing of p. But okay, when t is read and write borrowing p, and you try to print out p.h, this will fail. And the reason why it'll fail is because when t is borrowing p, t is pretty much taking full control of p, right? P is the owner, right? P is supposed to be read and write, but when you're telling t to be able to read and write p, then p shouldn't be able to change t, right? So t is going to do its handiwork, it's going to do its thing, and then after t dies, then p can reuse again. It's kind of like this, okay? I have a laptop. Okay, let's say I am P, okay? I am P. and I have some work that I do on the laptop. I have a presentation I need to give, and I need some help on my presentation. So I have a buddy. My buddy, his name is T, right? So I hand my laptop over to T, and I say, hey T, I'm delegate this task. You help me do some edits. So then T goes about editing my PowerPoint, just preparing my presentation, just making it better. Technically speaking, I am the owner of that laptop. I own the laptop, right? T is just helping. T is just doing the work for me. He's just writing up the slides. He's creating stuff for me. He's reading and writing. He's dealing with the thing. But for P, since I handed my laptop over to T, I can't do anything about it. If someone says, hey Jonathan, you have your presentation ready? Can we see your slides? Can we see? I'm like, hold on, wait a second. Because secretly, because on the side, I'm actually having T edit it. So right now, I actually don't have access to my computer. Even though I own it, I don't have access to the computer right now. So you got to ask me later. So it's kind of like that. What's happening right now is that T is actually helping P do a bunch of stuff on the person, and P cannot regain control over the person until T has finished the job. So I'm going to show you an example of finishing the job. Okay, so let's delete this stuff. So I'm going to create a scope. A scope is it's like a lifetime of variable. So let's say that let T is equal to and mute P. You know where T exists? T exists within these curly braces. After this ending curly braces, T dies. And when it dies, then P is going to regain control over the person, right? So over here, T print, all right, so T dot age equals to 6. And over here, I can print P dot age. Okay, so this works. What does it do? It's saying, okay, over here, you're creating P, and P owns the person, right? And within the scope, you have T. This is the region in which T is helping P editing the laptop work. You can think of it like that. So T over here. T has borrowed P mutably, so it's taking full control, and T is actually changing the age to a 6. But then over here, T dies, right? T gives up the rights again, right? T's dead. So once T is dead, it no longer points to P, and P now has full control. Like after this, so at this point, P now has full control, and now you can print out P dot age. And so when you run it, of course, you get 5 and 6, right? So here is when you print out 5. Here's the inner workings when T changes P to a 6, right? Here's where T changes age to 6, and then here's P dot age. But over here, while T is still working on the age, if you were to print out a P dot age, it would fail. Because right now, at this point, P has handed the laptop to T, right? So when T is working, T is not going to be disturbed, right? So even though P is the owner, P is not going to be able to touch the laptop because P essentially gave full control to T. So T is still working on the project right now, okay? But then, like I said, after the scope, after T is dead, after T no longer exists, then P regains control. Final things to note is that remember I said there's 2 types of references: regular reference and reference and mute reference. With this reference, the first one, which is read only, you can have as many as you want. Okay, so let's say I have this P right here is a variable. Let's say, right? You can make like an R and T and S and E, and just you can make a bunch of references that points to P. That's fine. Or if you have a P, you can have one reference like T, for example, that points to P. At any given moment, you can only have one mutable reference pointing to P, or multiple mutable references, or multiple non-mutable references pointing to P. So what I'm saying is that if you have a P, you can do and you can do like R, you can do R equals and P, you can do S. I'm not doing Rust syntax right now. This is just like shorthand. Okay? S equals and P, T equals and P. You can do all this, but you cannot do something like U equals and P. No, you can't have this because what's happening is that over here P is being borrowed mutably and immutably, and that is not allowed. You either only have this bit or you only have this bit. Yeah, that's all I have to cover today. So I hope you enjoyed and see you next time.